good afternoon, everyone, and welcome to another edition of nasscom Tech Talks. I am Vandhna Babu, Senior Manager Research at nasscom Insights. Today we are very excited to dive deep into the world of semiconductors with a special session featuring Mindgrove, a cutting-edge startup in this space. So as India moves towards the $1 trillion digital economy, startups like Mindgrove are at the forefront, driving the transformation towards a Viksit Bharat in 2047. So join us as we explore the groundbreaking work of Mindgrove and its impact on the semiconductor industry. A little bit about Mindgrove. Headquartered at the IIT Madras Research Park in Chennai, Mindgrove Technologies designs state-of-the-art, scalable, and reliable system on chips (SoCs) in India under the brand name Mindgrove Silicon. These SoCs are built to be power efficient and cost effective for use in IoT, vision, automobiles, and more. Mindgrove was founded by Shashwath T.R and Sharan Srinivas J, and it is backed by Peak XV Partners, Special Invest, and Whiteboard Capital. It is incubated by the IIT Madras Incubation Cell and IITM Pravartak Technologies Foundation. They recently also launched India's first commercial high-performance 28 nm MCU chip, which is called Secure IoT, delivering 70% of the high-end features at 30% lower cost than its competitors. So the website details of Mindgrove are mentioned in the description box below. Welcome, Shashwath. It is a pleasure to talk to you today and understand your company and your work. So thank you so much for coming.
Thank you for having me.
Thanks a lot. So I'll, straight away start asking the questions, dive deep into that. So first of all, I wanted to understand your journey. How did you start and how did you come about this idea of starting a company in the semiconductor space?
Well, to begin with, I didn't start a company in the semiconductor space. I started an electronics company, which just so happened to start making semiconductors as our first foray into the... I am an electronics engineer. I have nearly 20 years of experience now. And basically, cutting a very long story short, first of all, I wanted to build hardware. I wanted to build hardware in India for the kind of use cases that we are seeing in India. And when we started to build, the first thing that came to our mind, and we found that we needed components for it. We realized that we couldn't get those components that we wanted, or they were either too expensive, or they didn't have the features that we wanted, or it was just, they were not available in many cases. So the next thing was, let's try to build the component. Those components have other components that go into them, and those components have other... Finally, you end up at a point where you're like, you need to start building the semiconductors themselves, which go into these applications, because that is the fundamental thing that's driving everything else. And if we are having that problem at a small scale, everybody is having that problem. So that is one thread of it. The second thread is that we were incubated at IIT Madras. Our mentor at IIT Madras, Professor Kamkoti, is a semiconductor person. He is the one who ran the Shakti project for several years, which saw multiple prototype chips, microcontrollers and microprocessors being manufactured and tested. It is India's first processor IP, advanced processor IP in so many years. And so when we met him at this point when we were ideating, and then we said, sir, we would like to use the Shakti processor in something. When will it be commercially available? And basically, at that point, we'd already come to the point where we knew that nothing else was available. When we asked, when will it be available? He said, why don't you make it? It will be available. So that's basically how it ended. I mean, it's like, you know how to do this. You guys have the skills. You have you have my backing. IIT will give you all the tools and other knowledge. And crucially, IIT also introduced us to a lot of other customers who had similar problems or similar ideas on what to do. And we were able to work with them to create something which is a compelling product.
Got it. Yeah, because normally when you hear about startups, it's usually the buzz is around the software and the software side. So of course, it's so heartening to see that you've the journey that you've taken towards building this company. So one question that I want to ask was that what were some of the key problems that Mindgrove aimed to solve? So, and also where does it fit in the overall ecosystem of various players?
Okay.
Yeah.
So basically we're all digital people, right? Digital electronics, not analog. And we are also processor people, given our heritage from the Shakti Lab. So the chips that we build are very generic. By definition, microprocessors can do almost anything.
Yeah.
Only a question of the size and the performance that you get out of it and the power that it needs to power budget that it needs to adhere to when going into, for example, battery constrained devices as opposed to something which is running on your data centers. So we can do anything. Now the question is, what do we actually do which is impactful? And what do we do where we can actually sustain ourselves in the market? So off the bat, what we decided was we would not go after markets where there are very strong incumbents or very high barriers to entry, which make it very difficult to create a sustainable business. So things like the things like desktops, servers, which are all an Intel and AMD duopoly. Things like mobile phones, which is a Qualcomm, MediaTek, and Apple oligopoly. We decided we would not go there. So what can we do? We looked in the other direction. Instead of building big things, let's actually think of building small things. India is a market where consumer devices are exploding, IoT devices. We call all of this together IoT, embedded, small devices, things that you typically don't even think that they have a microprocessor, but they do. And we call all of these together, we call them the edge. They used to be called deep embedded, but now they call the edge because they're all connected devices today.
Yes.
So you have these devices which are being upgraded from being dumb, disconnected devices to connected smart devices. Everything from your from light bulbs to cars are becoming connected today. So we are working in this era of upgrade. We are trying to tap into this era of upgrade from the unconnected dumb device to the connected smart device.
Got it. Got it.
And we are building the picks and shovels that actually make, we are building the, not picks and shovels, the bricks and mortar that will actually allow our customers to build these buildings.
Got it. And of course, the semicon crisis that happened during COVID, that also, I mean, it's so heartening to see that, now, these are being built within India as well. So, I mean, so many other changes are also happening, which the government is planning. Yeah.
Let me just correct you or add context over here, right? We, as Mindgrove, are a design house.
Yeah, yeah.
We are called
True.
Fabless.
Yeah, yeah.
Mindgrove designs the silicon in India,
Yes.
and we get it manufactured outside as of now.
Yeah, yeah, yeah.
If there are, at the point that there are Indian fabs coming up, we can look at partnering with them for some or all or whatever combination of our product line.
Got it. Yes, yes. So, you're currently focusing on system on chip, and the focus is again on IoT. So, what are some of the advantages of SoC? And also in future, are you exploring some other use cases as well?
Oh, we're always exploring other use cases all the time. For example, we've been having a very active conversation with the automotive industry. It takes a while to make a sale there because of the product cycles, life cycles of the automotive industry, typically about 5 years. Which means that we had to have started 2 years ago to make a sale 3 years from now, which we did. So we had targeting making a sale 2-3 years from now. And we are always, we started in one domain and we are looking at everything across domains, across verticals to be able to sell our chips. See, the semiconductor industry has a unique problem that it is a very mass scale industry. So the only way for a product to be viable is either to have a massive market in one vertical, like let's say an Apple iPhone, or the chip that goes into the Apple iPhone, rather, a chip that goes into a mobile phone, or be so versatile that you can be applied across all kinds of verticals and you can aggregate volumes that way.
Got it. Yeah.
Right?
Yeah. Yes.
Yeah.
Great.
Sorry, I missed your other question.
The other is that like advantages you have mentioned that in future some other use cases. So
Yeah.
you've spoken about that. Yeah, that's fair. Yes. So now you are incubated at IIT Madras. So what advantages did you feel that you had while getting incubated there vis-a-vis somebody else who does not have the backing and the prowess that is provided by the incubation cell at IITM?
There is almost no way that anybody is building a semiconductor company without being backed by some institutional or having some institutional help. Because even the tool costs, the software costs of electronic design automation tools, if we were to go out into the market and buy it, be astronomical. The third-party IP that we need to put into a chip would again be astronomical. And the ability to go to a foundry and get the foundry to listen to you and take your order prototype would be insurmountable. So being at IIT, being incubated under Pravatak, which is a technology innovation hub, and that gave us access to all of these things, first of all. First and foremost, without which this business is non-viable. The second thing is that IIT with its we are not. I'm personally not an IITian in any way, except for the fact that I grew up walking in and out of the campus and to meet friends or for culturals. That's about it. But I have been associated with the Shakti Lab, right? And that association means that I'm getting access to a lot of IP or a lot of skill, a lot of talent, which otherwise is not available. I can't go out and hire IITians. They're too expensive for a startup. But I can work with them as students. I can work with the people in the lab who actually train the students. And I can access the cutting edge research. I can work with people, with the professors and others who are doing that cutting edge research. And I can be the first to productize it. That's the second thing. The third thing is, by the name IIT, you get a lot of people walking in. Every single day, there's somebody touring the research park, big companies, government, foreign governments, foreign companies, Indian companies, VCs. You get a lot of traction. You get a lot of initial conversations going on by just being in this ecosystem.
Got it. Fair enough. Yes. So, you've spoken about automotive that you're exploring there. So any other possible use cases? So as you had mentioned earlier as well that you are fabless currently. So are you also exploring fabrication in the future?
No, fabrication of semiconductors is a $10 billion investment. 10 billion with a B. And it is something that is best done by chemical engineers and process engineers, not electronics engineers. So I will let people with a lot more money and a lot more of that kind of experience handle that. The whole semiconductor industry has been disaggregating like this. And this is a 30-40 year process. AMD used to have their own foundry foundry division. IBM used to have their own foundry division. Both of them sold their foundry divisions. AMD spun it off, and IBM sold their foundry division to that spin-off which AMD created, and that is called Global Foundries. NVIDIA, for example, the most valuable company in the world, therefore the most valuable semiconductor company, has never had their own foundry. Qualcomm never had their own foundry. Broadcom, MediaTek used to be part of a foundry called United Microelectronics Corporation in Taiwan. They split into MediaTek and UMC.
Yeah.
And the reason is that this is extremely complex and this is extremely complex. Trying to keep them together means that you do not get those economies of scale. It's best to split them up. So there is no there is no advantage in owning your own foundry unless you are doing something very special, some very special technology which is not mainstream semiconductors.
Got it. Got it. So any other use cases or any other industries being explored apart from automotive?
There are lots of other smaller segments or other niche segments. There are consumer electronics such as wearables. We are looking deeply into that space. There are all the other things which, like the power industry, in aerospace, in so there are so many different things that we are exploring all the time. It's not like we don't know all of these things. We have been talking about these for a while, but some of them, it's healthcare is a big one.
Yeah.
There are so many medical devices that in hospital and outside of hospital.
Yeah.
So all of these require you to research that domain. It has its own requirements, regulations, those kind of things. So we have to work on that.
Got it.
Be conversant with what is going on in that field before we enter it. But in terms of the chips themselves that we develop, there's nothing technical stopping my first chip, for example, from being used in a medical device. Let's say a monitor. There's nothing that stops it. It's just that we need to comply with the regulations and especially the safety standards. And it takes us some time to study that and then figure out which standards they are and apply for the certification, work our way through that process.
Got it. Got it. Great, great. And also, are you also exploring some other technologies like Gen AI into your entire design process or, something like that?
We actually tried. The results are hilarious. It typically ends up designing something which is, it starts writing actual production code and then it starts hallucinating after that. After a while, it starts regurgitating Wikipedia articles. So, no. But this is one of the earliest fields, forget Gen AI, but this is one of the earliest fields that started using a lot of data-driven machine learning kind of approaches. So if you take our chip alone, right, the first chip that we made, that has about 2 million transistors on it. Okay. Typical high-end chip, let's say an Apple M1 or M2, would be upwards of 1 billion transistors. Nobody's keeping that in their heads.
Yes, yes.
So there is a lot of algorithmic work going on to. So these transistors are a little bit about the process, right? These transistors are laid out as physically, they're built over multiple layers. Silicon metal, silicon dioxide, and a couple of other specialty stuff in between, some polymers and stuff. So one transistor might take like 3 or 4 layers of different things. And then there are layers of metal above it to connect transistors to each other. And all of this is etched.
Yeah.
So this layout of how the transistors are shaped and how the transistors are arranged on the chip is very important. And we typically use a hierarchical approach. We divide the chip into blocks. And those blocks are divided into subblocks and sub, and finally you get to the transistors and then the internal layout of a transistor. There have been experiments and there has been a lot of work going on in intelligently laying out the transistors themselves at the lowest level and then going up, and routing wires between these laid out. So today, the routing itself, nobody does it by hand. It's all machine routing.
Got it. Yes.
The thing that is very bad right now in the physical, this is called the physical design process. The thing that is really bad from AI in the physical design process is what we call floor planning, which is like gross placement of blocks in the chip. And that is the most active area of research in the field. It's still, Google was doing a lot of work on that actually for their own like TPU chips and things like that. But let's just say that the results are heavily contested.
Got it. Yeah.
And definitely not ready for anybody like us to use.
Okay.
Now this is the physical design part. The logical design part looks like normal standard software coding. We write software code, except that when we compile it, instead of producing an executable that you would execute on your computer, it produces a circuit. That is a different ball game altogether, and we don't see the efficiencies over there, which would. Excuse me, just getting a little. We don't see the efficiencies in that code from AI tools, which would be compelling enough for us to be able to use it. The human is much faster and much more efficient and much better at it today than the.
Of course. Yeah. Fair enough. Fair enough. Yeah. So, lastly, I wanted to ask you that, at this forum, there are various stakeholders involved in the industry. So what do what are some of your asks from them? How do we further develop the ecosystem? What do you want to share in case if you have anything to, put something out there? Yeah.
The ask is always the same at a very basic level. Consider an Indian chip.
Yeah.
Right?
Absolutely.
That's the first thing. The next device that you're building, the next thing that you're taking to the market, consider an Indian chip, consider an Indian ecosystem. And please keep the conversation open. That's the first thing.
Yes.
It can be cost competitive. It can be price competitive. It can be very, very value driven. Doing it in India, because our engineers are of a very high quality. We can get a lot of value out of it. You don't need to be the cheapest, but if my chip is a little bit more expensive, but the device itself becomes 10 times as performant.
Yeah.
Or if the value of the device is that much better, that is something that should be considered. The second is, rather than just looking at the whole thing as a Gordian knot which cannot be cut, let's try to cut it and get into the market. Let's actually start building devices. It's already starting, so let's accelerate it. That would be my ask at a very high level.
Got it. Fair enough. Wonderful. So it was so great talking to you, Shashwath, and getting your insights about Mindgrow, about the work you do, and how the journey has been so wonderful to hear that. So thank you so much. And we do have more insights covered in our other videos on the tech sector. So to receive instant notifications when we post new videos, be sure to click the bell icon. And if you find this video interesting, please like, share, and subscribe on our YouTube channel. And do share it with your friends and colleagues. So thank you so much, Shashwath, for sparing time. So thanks a lot. Thank you so much.
Thank you.
Thank you.